Welcome back to Further Solutions Academy. Further Solutions Academy. I encourage us more to share and subscribe. If you have not subscribed before, kindly subscribe. Leave a comment also about the video. And if you want to reach us, you can reach us on this line. With this line, you can call us, you can WhatsApp us, and Telegram is allowed also. We have Telegram, either of the three. Okay, on this video, I'll be working on topology. That should be introduction part of topology, which basically I'll be on set. The outline of this video, the first one is concept of topology, and the second one will be basic concept of set theorem. That is what I want to work on this video. The introduction part of topology, because topology is the course that you start at final year student at final year undergraduate and postgraduate. That is is advanced mathematics. But let's try to explain some things on topology. Now let me start from this concept. Okay, let me start from concept. If I'm talking about concept of topology, what am I talking about? Okay. Now, if I'm talking about concept of topology, what I want you to understand that is this word, it contains topology. It contains two words, which are topo plus logy. These are the two words. Now, when we talk about topo plus two words, 1, 2, these two words made up topology. Now, when we talk about topo means, okay, let me start from logy. Topo means surface, and logy means study. That is, topo is surface and logy is study. Now this comes together to generate what? Topology. Now it means, if I should tell you about topology, it means study of surface. Surface. Okay. When we talk about surface in mathematics, it means we're talking about geometry. Geometry. Very, very important. That is what we talk about in topology. Now, if I should write it down in a normal sense, it means, if I should explain in a normal sense, it means mathematical study of geometrical properties that are preserved to the formation, stretching, and twisting of any object. Now, let me quickly explain what I just wrote here. If we are talking about twisting, deformation, stretching, for instance, if I should explain from this concept, Many lecturers will tell you that, talking about topology, he or she will be explaining due to shape, twisting a shape. For instance, we mathematicians, okay, let me start a common shape. Let me try to explain with a circle. This is my circle. I call this shape a circle. Now, if I twist or I stretch this okay, now this is the circle. If I stretch this circle, now I can stretch it. For instance, if I stretch this thing, it will surely get to ellipse. Now that is how what we are talking about on topology. Now, okay, talking about the topology in advanced sense. Now, this is just a way of introducing topology. Talking about topology in advanced sense, it means we will be talking about sets mostly. Now, it means what we have to stretch, or we are deforming, or we are in deforming, stretching. It means we'll be stretching sets. We'll be stretching sets. It means sets in advanced way will be referring to what? Sets of items. Now, just know that. Now, it means I have to introduce basic concept of a set. Now, basic concept of a set. Now, if I'm talking about basic concept of a set theory, now let me start with that, because this will take a lot of time for me, and by the end of the video, I think by the end of this I will end the video also. The first thing you need to understand is, at this point of advanced mathematics, we'll be using a set denotation, or set. Now, when we talk about set, what is a set? Set is a collection of identical items or elements. Now, that is what we are talking about. It says identical items or elements. Now, it's denoted by what? Capital letter. Denoted by capital letter, which is A, B, C. A, B, C. Okay, the elements on the set are denoted by what? Element or items are denoted by small letter B, C, and so on and so forth. Now, it can be numbers also. It depends on, it can be symbol, but that is what we are talking about. It means when we talk about set, it's always like this. This is a set B equals to A, B, C, D. Now, can you see this is a set and these are elements. These are elements. Now, on that set, this is a bracket we use on a set. There are different brackets in mathematics. We have big bracket, we have small bracket, we have and so on and so forth. But this is curly bracket. This is called curly bracket. That is what we are talking about on a set. Now, let me quickly explain other things that are very, very relevant to topology. Very, very relevant to topology. Now, don't forget, we are talking about set, concept of set. Now, the first thing I want you to understand is that, let me explain what is called finite set. Finite set. Now, if I'm talking about finite set can be set of alphabet. Now, set of alphabet. Now, set of alphabet. Now, if I'm talking about set of alphabet, you know that it has beginning and it has end. A, B, C, Z. That is set of alphabet. Now, if I also talk about another set can be big, it can be 1, 2, 3. This is a finite set. Now, this is finite set. And okay, another one, let me quickly explain what is called infinite set. Infinite set. Now, this time around, infinite set is talking about set that has beginning but no end. Example, if I have set A, contains set of natural number. Now, normally we use natural number in this form. This is how we write natural number when it comes to advanced mathematics. Now, this is how we write natural numbers. Okay, we have real numbers, set of real numbers also. You know, that one, it has no beginning. I mean, it has no beginning, it has no end. Natural numbers start from what? You know, commonly used number, which is 1, 2, 0, 3, and so on and so forth. But, okay, that is finite set. Another one that you need to understand is, another one set of, let me put B, set of real number. This is how we write real number in mathematics. Now, all these things, they are called infinite set. Now, let me quickly explain another one, empty set. Empty set. Now, empty set can also be called non-set. Now, it means empty set is normally in English we use a set that has no element. It means the element is empty. The element is empty. It's only denoted by something like this or something cancelled like this. Now this is empty set or non-set. It means there is nothing on it. The set is empty. We always use curly brackets, nothing, or zero, cancel. Now, another one we need to understand is called singleton set. Now, singleton set, it means it has only one element. For instance, if my A equals to, now, this is the set, this is the element. It means the element on that given set is 1. For instance, if I have B as 1, now this is the element, and this is the set, this is the element. It means it has only one element. And the next one we talk about sub and superset. Subset and superset. Now, when we talk about subset and superset, every element, note, every element in A is in B. That is what we all mean by. Now, then it means A superset of what? Of B. Now, it means what means, let me quickly explain it very well. I think I need to rub the upper part of this board. Okay, sorry, I'm still explaining superset. Now, what we mean is that this is the interpretation. This can be A, this can be B. Now, it means B is super set of A. A is subset of B. Take note of that. Take note of that very well. Because let me lay emphasis on this one, because there is another part that topology uses so much. Okay, now for instance, if I have, for instance, e.g., if I have A equals to 1, 2, 3. B equals to 0, 1, 2, 3, 4. Now, it means, what am I trying to talk about here is that A is a subset of B. A is a subset of B, and B is super set of A. Is a superset of A. Now, if I should write this in a symbolic form, it means B super. This is how to write superset of what? Of A. Please take note of that on superset. Now, let me quickly explain let me quickly explain equality set. Equality set. Now, equality set. Now, A and B are set, are set. Now, A in B and B in A. Therefore, A equals to what? B. Now, this is very, very important, this equality set. And how do I prove it? Normally, we use this statement in normal mathematics. A equals to B, which, now, when we have something like this, it means it implies both sides. A is a subset of B, and B is a subset of A. That is how to prove it. This is how to prove superset. Equality set. Anywhere you see it. Now, this is in A. It means I'm talking about this is my A, this is my B, and this also means this is my B, and this is my A. Take note of that. That is the normal way of studying. Now, let me quickly explain the next one. Let me explain what is called comparable set. Now, let's talk about comparative set. Comparable set, it means we are talking about set A and B are set. There must be a set. Take note of that. A and B are set. Two sets, either A is in B and B is in A. Then A and B are comparable sets. Comparative sets. Take note of that. The next thing is, let me move on to the next one. Let's talk about a non-comparable set. It means opposite of comparable set. Now, non-comparable set. Now, non-comparable set, it means opposite of what? Comparable set. Okay, don't forget set A and B. Now, it can be comparable, it can be not comparable. Are two sets. Normally, there are two sets. They are two sets. There are two sets. Neither A is not in. This is how to write is not in, because all these symbols are so matter to topology. Because in topology, you won't be talking in a statement form. Mostly, you use this symbol to call for whatever you are calling for. And is not in B, and B is not in A. It's called non-comparable set. Now, that is what we mean by non-comparable set. I think at this point you should get all this. We have done this in elementary, but this time around we are talking about the symbolic part of it, the symbolic pattern of it, and the understanding. Because at this point you are to apply it to topology statement. Now, and don't forget, topology is a study of mostly is a study of shapes, structures, geometry, but in advanced learning, we'll be using set to talk about that. Okay, now let me move on to the next one. I'm talking about mathematics. It's very important to be here. Now, the next one is family of sets. Okay, now family of sets, take note of this. If I have a set A equals to, now this A, this is B, and this is C to Z. Now, can also say that A equals to AB, A, C, D. Now, this is a family of sets. Take note of that. Now, this family of sets give birth to power sets most time. Give birth to power sets. Now, it means if I'm talking about, let me quickly explain power set. Power set. Now, power set, which I have A equals to 1, 2. Now, A power, this is how we write power set. P of that particular set. It will be equals to 1, 2, and 1, 2, and empty. That is power set. Now, if I should get the cardinality of my power set, or the items, the number of items is on the power set, this is what we normally use. N raised to power n, 2 raised to power n, 2 raised to power n. Now, n is the number of items in a given set. It means at this point, my n equals to 2. If I have 2 raised to power 2, it will be giving me 4. Can you see that? 1, 2, 3, 4. That is what I'm talking about. If it is, for instance, my B equals to 1, 2, 3. It can be A, B, C. Anyway, A, B, C. Now, my power set, P of B, cardinality. Now, this is how to write cardinality. It means the number on a power set. It will be equals to what? 2 raised to power 1, 2, 3. Power 3, which is going to be what? 1, 2, 3. That will be equals to 9. 2 raised to power, that will be 8. Now, if you check this very well, the power set itself, you will notice that it will be like this. A himself, B himself, C himself, and AB, BC, and AC, ABC, and MC set. Now, this 1, 2, 3, 4, 5, 6, 7, 8. Can you see that is power set? Don't forget, if it is 4 items, it means it will be powering 4, and you split it like that. That is what we are talking about on a power set. Now, let me move on to the next one. Okay. Now, the next one I'll talk about power set. Let me quickly explain universal set. Universal set. Okay, universal set. Okay, universal set. Now, universal set is just like universal set. Now, when you talk about universal set, you also call it feast test. Feast set. Now, it's always denoted by something like this, or some people use something like this to denote it. Now, anyhow, anyway, most time you use this thing to denote them. Now, mostly in advance we use this for build. I think when you get to advanced level, but this is always general, Now, when we talk about universal set, for instance, my universal set is equals to 1, 2, 3, 4, and so on and so forth. Now, it means, can you see that this does not end? It is infinite. It is what? Infinite. Now, if I have my set A equals to what? 1, 2, 3, 4 to 10. Now, can you see my set A is, this one is infinite, this one is finite. Now, if I should explain to you now, can you see the difference between universal and what? The set A. Set A stop at 10. Universal does not have limit. It means universal is just like a container is what you do most on your Venn diagram. You know, this is a universal set. That's why your teacher will tell you that, or your lecturer will explain to you that this is universal. Now, this is a set inside the universal. This can be a set, and a set. They are all set, they are all belong to what? Universal set. Can you understand what I'm trying to say? That is what I mean by what? Universal set. It's just a container that contains all the elements in a given other elements. Okay, now it's denoted by that. I've explained to you. Now let me quickly explain what is called union set. Union set is denoted by U. Take note of that. It's already denoted by U. Now, if I have AB, A union B, it means indirectly in topology, this is how they will write it. X, it means S is a member of A, and comma, S is a member of what? Of B. Take note of this. This is now, at this point, I'm speaking in form of what? Topology. Now, it means S belongs to A, S belongs to what? B. Okay, that is what I mean. For instance, A equals to 1, 2, 3. And B equals to 0, minus 1, and 8. Now, A union B, A union B equals to minus 1, 0, 1, 2, 3, and 8. Can you see? That is union. It means what contains what? The set. Now, in an advanced way, when we are to talk about it in topology, because all these things I'm relating them to what? Topology, it means I'll be having something like U. We call it index, which is I belongs to what? Big I of AI equals to X, that is to say, X belongs to A from some I belongs to what? Big I. That is, in advanced way, this is how I will write it. This is how to write it in advanced way. Now, index, it means the union of it. If I want to interpret it normally, to normal interpretation to primary school students, it means I'll be talking about what? A1, A2, A3, and to 8n. It means last time, first time, last time. Now, at this point, I'm interpreting what is given to you. The index is just the high. That is what I'm quoting there. Now, okay, now let me quickly explain the next one, which is intercept of a given set. Intercept of a given set. Now, if I'm talking about intersection, it means common region between two or more sets. That is an English statement. Common region between two sets. Intercept of a set. Common region between two or sets. It means A intersection B. That is the notion. This is the notion of intersection. Now, in a statement in topology, X, that is to say, X belongs to A, and B, S belongs to B. That is what I'm talking about. That is what we are talking about. Is an intersection now. It means if I have A 1, 2, 3, 4, I have B. B is 1, 3, 5, 7. Now, A intersection B will be equals to the common region is just like 2 is here, 1 is here. What else can we refer to? It means intersection is 1 and 3. That is all. That is all what I'm saying. Now, if I should write it in an advanced way, it means my n of I of index of AI equals to X, that is to say, X belongs to AI, And for all, this is how to write for all. I is an element of what? I, big I. That is what we are talking about. Let me quickly explain what is called disjoint. Disjoint of a set. Now, disjoint of a set, it means the intersection is empty. The intersection is what? Is empty. There's nothing on the intersection. That is what I mean by disjoint. Now, before I end this part, let me quickly explain what is called let me quickly explain what is called different. Let me explain what is called different of sets. Now, different of a set, A and B denoted by A minus B, which means X for S is in A and S is not in B. That is what I mean. For S is in. And if I have it B minus A, the story will change by saying that what? S for all S belongs to B, and for S not to belongs to A. I mean, yes, A. That is what I mean by what? That is that. Now, if I have, for instance, because this is another part that is very common in our topology when we are asked to prove, my A equals to 1, my A equals to, due to time, I will continue in the next video, which is a different of sets. Different of sets. Don't forget you are home with further solutions academy. Thanks.